Remember how you learned about sine and cosine trig functions? Yes, the unit circle is back. We have placed the yellow dots in the same locations as most teachers when they introduce this subject, namely 0, pi over 6, pi over 4, pi over 3, and pi over 2. Then we repeat this over all 4 quadrants. I am clicking on the dot in order to increase phase from 0 all the way around to 2 pi. Of course, 0 is the same as 2 pi and 4 pi and so on. Remember that sine is the opposite over hypotenuse and cosine is adjacent over hypotenuse. However, for the unit circle, the hypotenuse is 1. So the sine is just the opposite in red, and cosine is just the adjacent line in blue. Notice that as I am clicking angles, the exact sine and cosine segments are moving to their proper place on the graph for that angle theta. Also, the values x, which is cosine, and y, which is sine, are calculated above the unit circle as both the exact values and the decimal approximation. You can see how the blue cosine curve is the same as the red sine curve shifted by pi over 2 degrees. In other words, cosine of theta equals sine of theta plus pi over 2. Because of this, as we move forward, we will focus on sine. The graphs to the right are in terms of angle theta only. There is no concept of time yet. Whether you go around the unit circle quickly or slowly, the graph looks the same. Later, we will add time to our graphs, and the x-axis will be the time in seconds instead of angle theta in radians. Of course, angle theta will be related to time, since theta equals 2 times pi times frequency times time. It will become clearer when you go to the next pages of this section. Once we learn about frequency, then the wonders of music, wireless technology, motion, and countless other things will open up to us. Try all of this on your own after this demo. If you are on a mobile device, you may have to expand the yellow dot size to be able to hit it with your finger.